Hello, am I audible? So last week some of you have asked to solve some problems on transfer function based and pole zero based. So we can solve some of those problems. The first problem, we'll write down the forward transfer function they have given of a unity feedback system. That is, it's a negative feedback with unity gain. The question is whether the system is stable for what values. First option is k less than -1. Second is k greater than -1. Third is k less than -2. Fourth is k greater than -2. They have given a transfer function which has gain k, which is unknown, and they are asking whether the system is stable for what kind of values of k. The catch here is the overall system stability can be well recognized from the closed loop system transfer function. But they have given forward transfer function gain here, right? So if we find the stability, if I ask what is the stability, stability is in terms indirectly refers to the position of the poles or the position of denominator factors or roots. Whatever way you can think of, you can think of it. Everything is similar. So whatever is there in the denominator position, that refers to the poles of a system. So this what is the position of this poles, that refers to the stability of the system. If the poles lies on the left half of the S plane, that means the system is stable. If the poles lies on the right half of the S plane, the system is unstable, because it will create an unstable behavior, because that will give you the positive poles of, let's take this, I'm considering -2. So when we consider this will gives you e power minus ht, this will gives you e power minus 2t, this will give you e power 2t. This creates an unstable behavior while this creates a stable behavior. That's why we call whatever lies on the left half of the S plane, it is stable, right half of the S plane, that is unstable. Okay, now if I look into this gives what are all the poles location. S equal to -1 one pole, S is equal to -2 one poles. So both the poles lie in the left half of the S plane, right? -1, -2. Can I conclude the system is stable always? Will it be correct, or what is the catch here? Consider it as a forward transfer function. Forward transfer function in the sense there will be g of s it will be y, or if I take a feedback that is h of s, this will be, there will be some summation, let's take. So this will become r. Okay. So they have given only this information, g of s. The problem here is you cannot conclude anything with the forward transfer function. You should find the closed loop transfer function that is in the form of g of s divided by 1 plus g of s into h of s. That you have to find first. Then you can conclude the location of poles and the stability of the system. So here g of s they have given, and for h of s they have given a hint that it is a unity feedback system. So h of s would be 1, right? So since it is a unity negative feedback, I'm going to put plus here instead of minus. So the closed loop transfer function would look like this. What is g of s? K into s square plus 1 divided by s plus 1 into s plus 2 divided 1 plus whole by 1 plus the same transfer function g of s by into 1, right? So I'm going to keep the common term there, s plus 1 into s plus 2 plus k into s square plus 1 whole by the same denominator. This denominator and this denominator will get cancelled. Overall, you would end up having k into s square plus 1 divided by s plus 1 into s plus 2 plus k into s square plus 1. Right. If I simplify this, you will get s square plus 3s plus 2 plus ks square plus k. This again will give is 1 plus k into s square. So if I make any mistake, just let me know, okay? 1 plus k into s square plus, there isn't any s term, so I'm taking s as it is, plus 2 plus k. This is the, okay, right. So this is the overall transfer function, closed loop transfer function. 1 plus k into s square plus 3s plus 2 plus k. This is the denominator term, closed loop transfer function, let's take. So this would be your y of s by r of s, the closed loop transfer function. Right. Now you can say the stability of the system. For stability, you will look for the denominator, that is the poles or the roots of the system. So if I take this denominator, I am going to find the factors of the system. To find the factors, I am writing in terms of the characteristic equation, equating the denominator to 0. This means you are writing it in terms of a characteristic equation to find the roots. So now there is a shortcut. Since it is a MSQ, that is a multiple choice question, you can, instead of finding the k values, you can just put the k value whatever is there inside. Let's take, they have given these 4 choices, right? Minus 1, minus 2, greater than minus 2. Just try to put these values inside it. So if I put, if I consider k equal to minus 1, this term will go cancel, go to 0. This will become 3s plus 1k is equal to 0. So this will give you, I think that will be easy in this case. Instead of putting, because it is in inequality terms, I am going to find the transfer function root itself. That will be easy. This will give you, for this system to be stable, or if your roots are to be stable, that should be in terms of s plus a into s plus b, right? So for this to be stable, all the coefficients should be positive. So all this coefficient, what is there before this thing, should be positive. So 1 plus k should be positive, 2 plus k should be positive. So to make this thing work, what option out of this will be working? Can you solve and let me know? This will give you k should be greater than minus 1.
Greater than -1.
Right. This will give you k should be greater than minus. So out of these two, what is the safer option from the given options? First option says k should be at least greater than minus 1. Second option says k should be at least greater than minus 2. So if I pick this option, I can consider, meaning that I can consider k equal to minus 1.5. Is it right? So this won't satisfy that condition, right? So we have to pick this condition. This is the most possible way to choose the condition. The answer is k should be greater than minus 1. Clear? So if there is, if this k is, if you choose a value that is greater than minus 1, overall system will be stable in terms of closed loop, right? Not a open loop, and we are not interested in open loop right now based on this question. So if you have been asked this kind of question, just try to find the hints from the question. If it is a forward transfer function and you have been asked to find this k, there is no relation between k and the denominator, right, to make it, to say whether it is stable or not. So you have to find the closed loop transfer function from there. See whether they have system any feedback values. If it is not given, consider unity negative feedback system and proceed with finding the closed loop transfer function. Then closed loop transfer function, find the characteristic equation, roots that gives you the poles location or the condition that is to be satisfied to make the poles in the left of the SP. Pick that option, that will be the correct option. This is the steps to solve this kind of problem. I hope this is clear. If you have any doubt, just turn on your mic and let me know. I can move ahead with the next question, I think. Right. The next question is, one minute. I will give a similar problem and let you solve this one, and we can discuss the answer. Okay. The second question is, similarly, consider a unity feedback system. Solve it with forward transfer function g of s is equal to k into s plus 3 into s plus 5 divided by s minus 2 into s minus 4. Right. The question is the range of a to ensure stability. Option A, k greater than 6/8. Option B, k less than or equal to minus 1, or k greater than 3/4. Option C is k less than or equal to minus 1. Option D is minus 1 less than k less than 3/4. Can you solve this problem? Same problem. They have given forward transfer function, that is only g of s, and they have given it's a unity feedback system and ask you to find the k value to enter the stability. So the step 1 is find closed loop transfer function. Step 2, equate or write it in terms of characteristic equation. Third step, find the condition so that poles are in left half of the SP. So these are all the 3 steps you have to follow. Can you solve it? First is equal to k into s plus 3 into s plus 5 by s minus 2 into s minus 4. This will become k into s plus 3 into s plus 5. The denominator comes as it is. Right? I hope you all solving with me. If you find answer before me, let me know. Or if I do any mistake, let me know. This would be 1 plus k into a square minus xs plus 8s plus 2s. Oh, sorry. Should be 8 minus 8k minus 6 into s, right? Plus 15k plus 8. This is a constant term you will get. A into s plus 3, s plus 5 divided by this characteristic equation. This characteristic equation, if I equate it to 0, you can get the roots or the poles out of it. Now, for it to be stable, all these coefficients should be positive. Right. So 1 plus k should be greater than 0 is the first condition. 8k minus 6 should be greater than 0 is the second condition. 15k plus 8 should be greater than 0. This will give you k should be at least minus 1. This will give you k should be at least minus 3 by 4. This will give you k should be at least greater than 8 by 16 minus 8 by 16, 15, sorry. Right. Now the options are k should be greater than 6 by 8, k should be less than or equal to 1, or k should be greater than 3 by 4, or k should be less than minus 1, or minus 1 less than k less than 3 by 4. What option could match better? So these are all the options it should satisfy. Out of this, what could be the possible options?
Excuse me, ma'am.
Yeah.
Isn't it k greater than 3 by 4?
Okay, okay. Uh, yeah, yeah. There is a minus here, right? Okay, I made a mistake. That from this, now tell me what could be the best possible option. Eight by 15 would be 0.533, right? 3 by 4 would be 0.75. Now come to a conclusion. Which option should match better? If I take minus 1 is here, 3 by 4 is here, minus 18 by 5 should be here, minus 18, sorry, 8 by 15 would be here. So if I want to choose option, what should I choose?
D.
What? is the extreme value, right? So whatever value it is greater than either 3 by 4 or minus 1. Whatever value that is in extreme to this, that will be positive from this. Don't consider this as a, sorry, as plane. This is to help you visualize how it looks like. Maybe this is misleading. I will try to stick on to the numerical value. So out of this, the option would be k minus less than or equal to minus 1 or k greater than or equal to 3. Right? Good. Now we'll see some other question. Good. I will give you an exercise where I am giving a closed loop transfer function, that is T of s. It is equal to s cube plus 4s square plus 8s plus 16 divided by s power 5 plus 3s power 4 plus 5s square plus s plus 3. Now try to tell me the number of poles in left half of TS plane and right half of the S plane. How many will be in the left half? How many will be in the right half? One thing you can see is the highest power is 5. So the total number of poles should be equal to 5. Now you have to tell how many will be in left half of this plane, how many will be in the right half of this plane. If the system is stable, all 5 will be in the left half. Or unstable, any one from one pole to 5 poles can be in the right half of the S plane. So try to solve this and find the poles by equating it or finding the characteristic equation, and then tell me the location of poles, and then we can count from the poles whatever is in the left half or right half. Can you solve? If you face any difficulties, let me know. Anyone facing any difficulties? Yeah, please go ahead if you have any problem with this. Yeah, tell Ragini. Working. Okay, actually the problem here is up to third degree you can solve, right? Finding the roots of a equation will be easy. After third degree it will be very difficult to solve by hand. So that's why we have a criterion called Raoult-Horwitz criterion that will let us solve the problem easily. But this is the content that you get in week 5 or week 6. So I will just give a gist about it. Now you will expect maximum SQ in this quiz one. You won't have to solve all these complex things. But it goes like this. Just I will give you a hint. Okay. You have to write the equation like this. So when there is a coefficient here, if you take the characteristic equation s power 5 plus 3 s power 4 plus 5 s square plus s plus 3. This is the denominator, right? So you have to write it in one particular order, where you have to first choose the odd numbers or odd degrees first. For example, these are all odd degrees, right? And this is one. This is considered to be one, that is odd degree. Power 3 is not there, so consider it to be 0. So write the coefficients of odd degrees first. in a first row. So this would be 1 s power 5. There is the coefficient of s power 5 is 1. There is no s cube because there is no coefficient. So I'm putting 0 for it, and let me make it a full stop. Okay, so I'm putting 0 for it, and the other coefficient s power 1. So the coefficient of that one is 1. Did I make any mistake right now? Okay, this is 1. Now, second is coefficient of even degrees. That should be written in the next row. That is s power 4. Coefficient of s power 4 is 3. Coefficient of s power 2 is 5. Coefficient of this considered to be s power 0. So that is 3. I'm going to write it here. Now what you have to do is you have to multiply this way first. Then you have to multiply this way. Then you have to subtract the red minus black. Red minus black. So this should be the first multiplication. This should be the second multiplication. Then minus 1 minus 2. Number 1 minus number 2. For example, if this is 1035, multiply this, it will be 0, right? Then multiply this, it will be minus 5. So you have to write, and you have to divide it by this term. Where you are going to write that term, you have to divide it by that. So I'm going to write minus 5 by 3 here. What I did is I multiplied this first, then I multiplied this term second, this black term second, then I minus both of them, then divided by this place value. The next time what I am going to do, I have to repeat the same step. Similarly, I will do this. First, I will multiply this 5 into 1 minus this one. This is first, this is second. 0 into 3 divided by 5, where I started. That is 5. So this will give you 5 by 5, it will be 1, right? So this will become 1. So there is no other thing to multiply, so I am going to leave this place as it. Now I am going to repeat the same thing again. Multiply this again, subtract it and divide it by this term. So this will give me minus 5 by 3 into 5 minus 3 whole by minus 5 by 3. This will give me minus 25 minus 9 by 3 divided by minus 5 by 3, right? This will give me, what will be the answer? Minus 14 by minus 5, right? 14 by 5. That would be the answer, right here. After doing all these things, until the last one value you are left with, you should do all this thing again. Now you have this, right? I can multiply this. Since there is nothing here, I am considering this as 0. So 3 minus 0 divided by 1, that is 3. Again, I am doing this here. 14 by 5 minus, this would be 14 by 5 minus, I think it won't be that easy at first to see, but later you would pick up. 25 plus 14, 39 by 14, right? Answer I would left with 39 by 14. So there is nothing to multiply, so I'm leaving until you get first thing. One single term, you have to do all these steps. So this will be belongs to s power 5, this belongs to s power 4, s power 3, s power 2, s power 1. Right, I have to do again one step, right? This becomes 0. So this will give you 39 by 14 into 3 minus 14 by 5, 39 by 14 I'm going to use the calculator as this. 2.78. 2.78 into 3 minus 15 by 5, 5.54 divided by 2.78. This will give you 1.9. 1.9. Right. Okay. So these two terms are zeros. I'm left with this. So this belongs to s power 0. So after finishing all these things, you have to look for any change in the sign. So if you see here, there is one change in the sign. I'm going to do this in terms of Greek. Here positive, there is no change in between. Here it changes once, first change in the sign. Then you see again it changed from negative to positive. There is the next change in the sign. So if you look for this change in the sign, two change in the first column of the table. So this means two poles are there in the left right half of the S plane. If there is any, there isn't any sign change. If it starts with negative and ends with negative, or if it starts with positive and ends with positive, it means there are no poles in the right half of the S plane. You can check this condition for simple a square plus as plus c or b thing also. It will work for any degrees. So this will give you how many poles. For this question, two poles are in the right half of the S plane. Remaining three poles are in the left half of the S plane. That's how you find for higher degree terms. So you can see this in detail how you can find all these things. Just I gave it just to you. Okay. Okay, I will give you four options. Just try to tell me what are the system that are unstable. I am giving closed loop transfer function. Okay, you can straight away find it. 2 by s square into s plus 2. Third is 2 by s into s plus 2. D fourth is d into s plus 1 divided by s into s plus 2. So can you tell whether all the systems are stable or unstable for each of the systems? Try to find. I will be back in 2 minutes and we can discuss the answer. Somebody typed something, right? What did I do? 1, 3, and 4 are stable. 3 is unstable. Yeah, it's closed loop transfer function only. It's closed loop transfer function. Is unstable. Okay. 1, 3, 4 stable. Ragina is telling. Manisha, if you find, let me know. And rest all people, type it in the comment box. What do you find? It's for closed loop system. You don't have to find closed loop transfer function. Okay. Only one is stable. Manisha is telling. Based on it, the rest of the things, Pratham.
Ma'am, the second and second level both are partially stable.
Partially means marginally stable, you want to say.
Yes, ma'am. Marginal.
Right, okay.
Ma'am, 1 and 3 are stable.
1 and 3 are stable, you are choosing.
Sure.
Right.
And 2 have poles on 0, 0 and -2. So
Mm-hmm.
that also stable means and
Okay, right.
yeah, ma'am, all are stable.
Okay, you are choosing all are stable. Right, okay. Okay, good. Let's see. What are all stable? What are not? Okay. First thing is s plus 2 equal to 0, then s is equal to minus 2. Stable?
Yes, ma'am.
Okay, good. Second thing is s square into s plus 2. This will be s cube plus 2s. Okay, let's take, even if you consider this will be s is equal to 0. Two poles are at 0, 0,
Zero.
and s is equal to minus 2 will be the
Minus two.
another pole. Good. I can say this is marginally stable and this is stable. One pole is stable, another pole is marginally stable. Okay. The third option is, what did I do? S plus 2. Okay. So for this, the s plus s into s plus 2, this will again, one will be in the origin, one will be in the minus 2. Similar to that. Marginally stable one, stable another. Right. Another will be s into s plus 2. This, oh, both are same, right? One will be here, one will be minus 2. So when you individually measures for all the system, that is, if I consider this to be a closed loop transfer function, you are getting all the system as either poles are either marginally stable or stable. I am, for now I am considering all to be stable. Everything is in the either in 0 or left off of the s plane. Okay. Now we will consider this as a open loop transfer function. That is the forward transfer function, only g of s. And I am telling we have a unity feedback system. Now can you find the whether the systems are stable or not? The same transfer function, but it is not closed loop, it's a open loop, that forward gain transfer function. Now find the closed loop transfer function and see and say whether it is stable or not. Just type in the chat box. the chat box for all the systems. What do you think is stable? What is not unstable? Quickly finish and wrap up. Let me know when you solve. Just type in the chat box.
Are we considering HS or not?
What?
Are we considering HS or not? Or HS equals to 1?
One,
We are
one.
considering. So for GS also it's like the previous answer, all are stable like what you have done on the right side.
No, you have to find the closed loop transfer function, right, for all the systems.
Oh, that was for open loop, no?
No. Yeah, I'm telling that all this thing I'm giving now, consider it as GFS, not closed loop transfer function. For first ones, I asked you to find for closed loop transfer function, considering it as a y by r. Now consider it as only g, and then consider h is equal to 1. Find closed loop transfer function for each of the systems. Let me solve with you. So the first question would be 2 by s plus 2 by 1 plus 2 by s plus 2. This would be,
Stable.
yeah, it should be s plus 4. So gives you s is equal to minus 4. This is stable. First question is stable. Second option would give you 2 by s square into s plus 2, right? This gives you 2 by some denominator, s square plus s plus 2, sorry, s square into s plus 2 plus 2 by the same by the same denominator, 2 by s square into s plus 2 plus 2. So if I find, if I write a Roth-Hartwig's equation for this s cube s square s power 1 is 0. Odd terms first, 1, 0, s power 1 is not there, s square will be 2, 2, then this will be 0 minus 2 by 2 minus 1, this will be minus 2 into minus 0 divided by minus 1, this will give you 2, right? Now there is one sign change here. You see this, there is one sign change from two sign change, positive to negative, negative to positive. So 2 poles are in RH, this right above this, unstable. Second
And
is
the third and
right. one is 2 by, we will solve this simultaneously. Then u into s plus 1 by s into s plus 2, similarly. So if I take a closed loop transfer function, this would give me by s square plus 2s plus 2. If I make any mistake, please let me know. S square plus 2s plus 2s plus 2. There is all the coefficients are positive. Here also all the coefficients are positive. So both will be stable, right? So only option 2 is unstable. So this is the difference between the open loop transfer function and the closed loop transfer function. When you consider only this system that has only g of s, if I'm giving a output r and getting a input r and getting an output, but in the closed loop case same thing is happening, but I'm considering one feedback input. Right. Mostly we tend to say closed loop systems are stable when compared to open loop system. It is not like that in this meaning. For example, in this case, all the four systems tend to be stable. You said all the four systems are stable. But when you consider the closed loop system, you found out the second system is unstable, right? So sometimes this feedback creates a disturbance that inside the system that makes this marginally stable system to go from the midpoint, the marginally stable to unstable. That is the one case that happened in the right hand side. So this is some intuitive explanation behind that. The marginally stable can anytime be stable or unstable. So in this system, in the system behavior, based on the poles, another pole location, it pulls the system towards the right of case plane. That makes it unstable. Right? Clear? That's it for today. If you have any doubt, you can ask. Otherwise, you can leave. I will post this notes as now itself.
Yeah, sure, ma'am.
Right.
Yes, ma'am.
Thank you.
Yeah, thank you, ma'am.
Thank you. Yeah, if the pole is in the imaginary line, anywhere in the imaginary line, not even in origin or anywhere in the imaginary line, we call that as a marginally stable. It might sometimes, because of another pole's behavior, it might go here or go here. We don't know where it goes. So that's why we call that special case as marginally stable. We cannot decide based on the poles. So anything other than that, other than the pole location, whatever poles there which are in left of or right of, that will decide whether the system is stable or unstable.